Okay, welcome back. This is a recap of anti-differentiation by parts. This is going to be pretty straightforward and simple. Thing one, the formula. You don't need to know how to derive it. You do need to know the formula. Thing two, how do I choose U? How do I choose dV? Pretty straightforward list. And here's the deal. If you pick the wrong thing, it'll look more complicated. If it looks more complicated, go back and pick differently. So what do I do for choosing U? Well, thing one, if there's a natural log, you always choose the natural log. The derivative will be 1 over x. Boom, just got simpler. Thing two, you choose something that gets more simple rather than less simple. A polynomial always gets more simple when you take the derivative. Thing three, if there's an inverse trig function in there, you're probably going to choose the inverse trig function. How do you choose dV? Well, you choose something that doesn't get more complicated. That's what it boils down to. If it gets more complicated, your next integral is going to be harder, and it's just going to keep getting harder. So I've written out the examples that we did, and I'm going to go ahead and just circle. So notice that U, polynomial, x, U, polynomial, x squared. Let's skip that one for just a second. The e to the x cosec U, natural log, U, inverse trig function. So let's go back here. This was the one where we did it twice and then ended up with our original derivative. If you wanted to play around with it, you could switch them, let dv equal e to the x and u equal cosine of x. But what you're going to discover is that u doesn't get more simple. U is then switching, and I've sort of veered off a little bit. I don't want to take the time to do this example. It doesn't work as well. And again, play with it, see what happens. And I think I might even cut this little bit out well, I don't have a timer. So in this case, we chose e to the x to be u because the derivative, even though it doesn't get simpler, at least it stays the same. And then looking at our dv's, we chose doesn't get more complicated, sine of x, doesn't get more complicated, e to the x, doesn't get more complicated, sine of x, gets a little more complicated, but this is balanced by the fact that we got rid of the natural log, gets a little more complicated, but is balanced by the fact that we got rid of the arc sine. So they're no longer in our integral. And coming back to this middle one, I was actually talking a bit about this in the middle of this video, but I'm going to cut that bit out. This is one where if you play around with it, the idea is this is where you ended up circling around back to e to the x cosine of x dx, and then being able to collect like terms. So if you want to play with switching u and dv, make u equal to cosine x, dv equal e to the x dx. I haven't done that recently. Don't know if it's more simple, but as a general rule, try it. If it gets simpler, keep going. If it doesn't, go back and switch. All right. Thanks for watching. This has been chapter 7.3, integration by parts. Hope you learned something.